Look up. Right now, something in the thin air miles above you is traveling faster than a bullet. It's an F-22, a MiG-31, maybe even a silent, unmanned drone. And it's punching through the sound barrier with physics-defying ease. We accept it as normal. This incredible power, this mastery over friction and air density, represents humanity's pinnacle of engineering achievement. We did it. We broke the Mach wall.
Most people, when they think about modern air power, instinctively grasp one central concept: speed dictates survival. That belief is deeply woven into the fabric of military doctrine. It sounds so logical, so undeniably true. The aircraft that achieves the highest velocity gets to the target first. It minimizes the time spent in the deadly airspace of enemy anti-air systems. Faster means less reaction time for the adversary. Faster means the pilot gets home alive.
This simple, elegant calculus fueled the colossal Cold War arms race. It gave us the legendary titanium-skinned SR-71 Blackbird screaming at Mach 3.2, defying missiles simply through sheer, unadulterated pace. It was built on the premise that no missile, no radar, could catch a ghost moving 3 times the speed of sound. This logic is appealing. It's cinematic. It promises technological superiority through raw velocity alone. But this is where most people get it wrong.
The relentless, Cold War pursuit of raw velocity, the very obsession that birthed these terrifyingly fast machines, ultimately created a critical strategic flaw. That obsession led engineers down a beautiful, expensive, and ultimately self-defeating path. Speed beyond Mach 1.5 becomes a crippling liability. The physics are unforgiving. To maintain sustained supersonic flight, you must overcome brutal heat and friction.
The airframe needs exotic, expensive materials like specialized titanium alloys. The jet engines become fuel-guzzling monsters, severely limiting mission range and loiter time, the time the aircraft can spend actually operating over a target area. You gain velocity, but you lose endurance. You become an Olympic sprinter carrying a backpack full of gold bricks. You can run fast, but not for long. Engineers faced an impossible choice. Design a plane that goes Mach 2, but requires a tanker every hour and generates a heat signature visible for 100 miles. Or design a plane that goes Mach 0.9, but is almost invisible and can stay airborne for half a day. The answer, which the modern world has quietly embraced, contradicts the core belief that speed equals victory. The engineering reality slammed into the strategic reality. The aircraft that relies on speed alone is forced to trade stealth for velocity. Its engine noise, its heat plume, its massive radar cross-section, all scream, "I am here," to sophisticated surface-to-air missile systems. We spent decades fetishizing the sonic boom. We invested billions in pushing the envelope, only to discover the enemy didn't care how fast we were going. They just needed to see us long enough to pull the trigger. The modern doctrine understands a simple, ugly truth. Stealth beats speed, always. A slow ghost that stays unseen and can choose its moment is infinitely more lethal than a screaming titan that announces its presence 2 counties away. Think about the strategic shift from the massive, blazing F-4 Phantom of the 1960s to the sleek, subsonic F-35 Lightning II of today. The F-35 trades raw top speed for electronic warfare capability and a radar profile the size of a pigeon.
This fundamental, agonizing compromise, the sacrifice of sheer speed for operational longevity and invisibility,
defines modern aviation. The sonic boom became a symbol not of power, but of weakness. It's the sound of an aircraft advertising exactly where it is and exactly where it's headed. The secret history of supersonic flight is not a tale of triumph over physics. It's a story of recognizing the limits of speed and pivoting toward the silent, invisible threat.
That pivot rewrote the rules of engagement and set the stage for the conflicts we see raging today, where the expensive, complex speedster often sits idle, overshadowed by cheap, slow, persistent aerial terror. The reality of this compromise plays out on modern battlefields with horrifying clarity. Forget the Cold War. Forget the idealized dogfights. Look at Ukraine. Look at the Red Sea.
We are watching a brutal, real-time experiment dismantle the assumption that high-tech, supersonic platforms guarantee dominance. Consider the strategic mismatch. The Houthi forces in Yemen firing inexpensive, off-the-shelf anti-ship missiles and drones, forcing naval destroyers to launch million-dollar interceptors. Consider Ukraine defending its sky against swarms of cheap Iranian-designed Shahed 136 drones. These drones cost maybe $20,000 apiece.
They are slow, noisy, and fly low. Yet these cheap threats tie up multi-million-dollar air defense batteries and force the deployment of sophisticated $150 million fighter jets, jets designed to defeat Mach 2 rivals, to chase down glorified model airplanes. The cost-to-kill ratio is fundamentally broken. This disparity reveals the shocking failure of the speed-centric doctrine. Why deploy a $100 million supersonic jet requiring hundreds of hours of maintenance and a highly trained human pilot to execute a mission that a dozen cheap, persistent, remotely piloted drones can achieve with zero risk to life and at a fraction of the price? Supersonic speed does nothing to defeat a threat that is cheap, slow, and ubiquitous. Modern conflicts demand persistence, flexibility, and most importantly, affordability. They demand numbers.
A single F-22 Raptor, capable of blistering speeds, might be the most dominant fighter aircraft ever created. But its price tag means you cannot afford enough of them to cover a continent-sized conflict. Meanwhile, cheap unmanned systems scale instantly. They are expendable. They don't require immense, complex logistical tails, specialized hangars, or squadrons of highly paid maintenance engineers. They are the definition of asymmetric warfare, and the supersonic legacy is struggling to adapt.
Here is the uncomfortable truth, the one that the military-industrial complex rarely wants to admit. Supersonic capability has often become less about actual strategic operational necessity and more about national vanity. We build $200 million manned fighters that roar across the sky, not because they are the most efficient solution, but because they are political monuments.
They are tangible proof of industrial capacity, symbols of prestige designed to impress allies and intimidate rivals at air shows. They represent a cultural attachment to the manned aerial warrior, a hero in a cockpit, even as the data shows the optimal strategy involves an unseen operator miles away. These expensive, highly visible sonic performers are being rendered operationally obsolete, not by faster jets, but by cheaper, slower, more numerous unmanned systems guided by AI. The real battle is fought not at Mach 2, but in the realm of sensor fusion, electronic resilience, and critically, manufacturing cost. The ultimate irony is profound. The jets built at unimaginable expense to win the wars of the future are being grounded or used inefficiently, while conflicts are defined by technology rooted in garage workshops and commercial electronics. Speed is no longer king. Endurance, ubiquity, and invisibility hold the crown. The physics of breaking the sound barrier remain an incredible achievement, but the economics of war have effectively raised the sonic ceiling higher than any pilot can fly. The age of the screaming, manned fighter jet is fading into history. The next major technological barrier we face isn't Mach 3, it's Mach 5, hypersonic flight. But these vehicles, the next generation of dominance, are almost entirely unmanned glide vehicles and missiles. They travel so fast and so high that no human pilot can survive the G-forces or process the required reaction speed. They signaled the final definitive obsolescence of the human element in high-speed aerial warfare. The speed barrier has been broken, but in doing so, we rendered the cockpit unnecessary. The question isn't how fast we can push the next jet. The question is, who will control the silent, ubiquitous, unmanned sky that remains after the final sonic boom fades away?